Okay, this is day 15. It's doing Leetcode 75 and doing the nth Tribonacci number, and this is 1137. And the Tribonacci sequence T sub n is defined as T sub naught is equal to 0, T sub 1 is equal to 1, T sub 2 is equal to 1, and T sub n plus 3 is equal to T sub n plus T sub n plus 1 plus T sub n plus 2. For any n greater or equal to 0, and for even n, we have to return the value of T sub n. So if you're given n equals 4, you have T sub 3, which is equal to 0 plus 1 plus 1, which is 2. T sub 4 is equal to 1 plus 1 plus 2 plus equals to 4. So the result of T sub 4 will be 4. That's what we want to solve. And then for n equals 25, we have 1,389,537 as the answer. So you just have to do, there's multiple ways that we can solve this problem. One of the most inefficient ways to do it is using just basic recursion, and just saying that you given your base cases, keep trying to go down the stack call frames and trying to resolve each problem at a time. But it's very inefficient because you have to keep giving the result to each call stack going up. So you go all the way down to the most bottom base cases and you build all the way back up to like the largest n, and that just the space complexity and the time complexity is just very inefficient because you have to store all those stack call frames, and also because you have to in terms of just the computations, just inefficient as well, since you're doing recursion on top of that. There's two other approaches that I've thought of, which is one of them is using something called dynamic programming tabulation, which uses memoization. Essentially what this means is that we just store the resulting values. Tabulation is essentially just creating a table of the previous values that we compute and resolve. So essentially just caching them, and then we can use them in the final result. But there's also another way to do it. Since we only need to really know the last three values that we used, we can have constant space complexity. So with the tabulation, we have O of n for the number of inputs n being the number of inputs we're given. The input number we're given, it goes up to that amount to calculate all of the Tribonacci number. But as the O of n space complexity as well, since we have to store up to n amount of values, since we have to compute all the way up to T sub n. But with the bottom up approach, we can call it, because we just have to start with the smallest three elements and then build our way up. We have a space complexity of O of n, since we just need to store three variables, and we just keep incrementing every single time, since we only need to store the three most recent values. So we're going to go ahead and implement the bottom up approach. So essentially what you have to do is you have to define your base cases still. So you still have if n, or like these are the cases if you were given that n, you have to return that T sub n value. So if n is equal to 0, you can just return n. Well, if n is equal to 1 or n is equal to 2, you can return n as well, or you can return 1 instead. So just 0 and 1. And then otherwise, you have 3 pointers here, which is equal to a, b, and c. So a is going to be T sub 0, T sub 1 is going to be 1, T sub 2 is going to be 1 as well. So then what we can do here is say for I in the range from 0 and 2. So the third element, which is 2, so T sub n plus 3, which is 2 inclusive up to n. We can say that C is going to be equal to, because you see T sub n plus 3 is equal to T sub n plus T sub n plus 1, and place T sub n plus 2. So that means that C is going to be the summation of all of the three previous values essentially. So, and we can do an example here too, where if we had T sub 4, t sub 4 is just equal to t sub 1 plus t sub 2 and plus t sub 3. Well, yeah, and yeah, so that's why that's the summation. That's why C becomes the summation of it. And then C is eventually going to be the one that we're working as well. So we go forward using C. So B is going to be equal to C, and then A is going to be equal to B. I believe, yeah. Since we want to start moving A and B up, so that they are the T sub n plus 1 and T sub n plus 2. That should be the result.